Hello everyone. In this class we are going to discuss about industrial location theory of Alfred Weber. Where is the perfect place to build a factory? Okay, what is the suitable place to establish a factory? Raw materials, that means we need some kind of raw materials to produce a product. Then availability of labor, then distance to market and distance to raw material locations. All are some determining factors of any industrial locations. In 1999, a German economist Alfred Weber published Über den Standort der Industrien. Observing the rapid industrialization of southern Germany, he sought a mathematical formula for the ultimate business question: how do you maximize profit through location? Okay, ultimately he gives the least cost theory. Premises, demand is uniform, therefore wherever the cost of manufacturing is minimized, profit is maximized. Okay, it's depend upon the cost of manufacturing, the least cost. Methodology of the theory is a normative inductive model that isolates variable to find the single optimum spatial point. Now, there are some conditions establishing the boundary conditions. As a deductive model, Weber stripped away real-world cause to create a sterile, predictable geographic laboratory. Okay, he considered a isotropic structure or isotropic surface. Climate, topography, and soil are perfectly uniform. Okay, in this isotropic surface, the climate, topography, and soil of this specific location are perfectly uniform. All are same. No natural obstacle exists. Okay. Then uniform demand and pricing for the finished product are identical everywhere. Okay, there are similar demand for the final product. Then ubiquitous and fixed inputs. Materials are either evenly spread everywhere or anchored to specific known points. Then linear transport cost. Transport cost is scale indirect, constant proportion to distance and weight. Static labor pool, workers are immobile and will not migrate for jobs, through wage rates vary by location. Economic man, entrepreneurs are perfectly rational actors with complete information, seeking only profit maximization. Okay, these are some preconditions for establishing the boundary in Weber's least cost location theory. Now there are three pillars of spatial choice. Weber argued that irrespective of political or cultural conditions, industrial location is dictated by three universal forces. He calculated them sequentially, starting with a baseline and introducing disruption. The optimum location, pillar 1, transport, the primary baseline. The foundational geometry determined by distance, weight, and volume of inputs and versus outputs, input versus outputs. Pillar 2, labor, the first override. The magnetic pool of ship wages that can warp the transport baseline. Pillar 3, agglomeration, the gravity effect, the clustering of shared infrastructure that draws isolated factories together. Okay, now pillar 1, transport and the material index, MI, where MI is equal to weight of the localized raw materials. Okay, weight of the raw materials divided by weight of the final product. Okay, this is the formula: weight of the raw material and weight of the final output. That means final product. Transport cost is Weber's most dominant variable. Transport cost is the Weber's most dominant variable. To calculate the baseline location, entrepreneurs must calculate the material index, a simple ratio of inputs to outputs. This is the formula. If material index is more than 1, then scale tips toward resources. Okay, material more than product. If material is less than 1, that is scale tips toward market. Okay, not for the resources, it's towards the market. Material less than product. If the material index is equal to 1, that is perfectly balanced. Footloose, for example, footloose industry. Okay, these are three indications of this formula. The diagnostic matrix, industry spatial basis, dimension, weight loss, gross and weight gaining, pure and ubiquitous. MI value is more than 1 in weight loss and weight gaining. MI value is less than 1. MI means what is material index? MI means material index. Definition: raw materials are heavy, bulky, or loss mass duration processing. Raw materials gain weight volume during processing or are available everywhere. Example, water. Transport driver, it is too expensive to ship the raw waste, weight losing. It is too expensive to ship the bulky finished product. Location biased. Material oriented, factory is clustered directly at the raw material sources. Market oriented, factory is clustered as close to the consumer hub as possible. Classic examples, weight losing. Iron and steel. 4 tons of iron is equal to 1 ton of steel. Sugar refining. Iron weight losing. Then weight gaining, bulking, cakes, beer brewing, and cotton textile, etc. These are difference between weight losing and weight gaining industries in terms of MI value, definition, transport driver, location bias, and classics examples. Now the explanatory visible, the location triangle. When an industry requires multiple localized raw materials, location becomes a game of geometric tension. Okay, market, resource 1, iron ore, resource 2, coal. And this is the centroid P. This is the location. Node R1, heavy gross input, strong pull. Node R2, medium gross input, moderate pull. Node M, finished product, weak pull. Node P, the exact least transport cost point where the total cost of moving materials in and products out reaches absolute zero. It is not the geographic midpoint. Now, pillar 2, the labor cost override. Weber recognized that the geometric center is not always the most profitable. If a region offers exceptionally cheap wages, the savings can justify shipping goods over longer distance. Okay, least transport cost P, ship labor hub. Relocation is mathematically justified only if savings in labor expenses is more than additional transportation cost incurred by moving. Okay, real world reflection. This principle accurately predicted the modern offshoring boom, such as the shift of the US cotton textile industry to cheaper labor markets, or the rise of ready-made garment hubs in Surat and Tirupur. Decoding the Isodapane, the topography of cost. To calculate if a move to ship labor is profitable, Weber invented a topographical system of cost mapping. Okay, factory and critical isotopes, this is the boundary, and ship labor node. Isotope means thin rings, lines connecting places with equal transport cost. Each ring outward adds Euro 5 in transport penalty. Isotopes, lines of equal total cost, transport plus labor. The critical isotopane, think ring, the exit boundary where the extra transport cost matches the labor savings. The mathematical proof, the ship labor nodes offers Euro 15 in wage savings. The third isotopane represents a Euro 15 transport penalty because the nodes lies outside this boundary. Example, it requires Euro 20 in transport to reach. The factory cannot profitably relocate there. Okay, this is the concept of isotopane and isotemes in terms of Weber's least cost model. Pillar 3, the gravity of agglomeration. The final variable is the clustering effect. Even if a location is not optimal for transport or labor, factories will group together to share the immense cost of infrastructure. Critical isotopane, factory, and this is the agglomeration zone in terms of growth pool. The agglomeration effect means shared overheads, roads, electricity, grids, and port access. Ancillary networks spread access to specialized supplies and repair networks, knowledge spillovers, concentrated pools of highly skilled specialized workers. Weber's rule: when the critical isotopes of 3 or more industries intersect, the shared savings from agglomeration completely override baseline transport cost. The synthesis arc, the shifting optimum. Industrial location is not a static point, it is a dynamic negotiation. 1, the baseline, least transport cost, the labor override, and 3, agglomeration pool. Synthesis insights. Weber's genius was in creating a baseline from which the disruptive forces of human capital and shared economics could be mathematically measured. The final location is a geographic compromise of these 3 tensions. Okay, these 3 tensions: baseline, labor, and agglomeration pool. Real world geometry, for example, Tisco, Jamshedpur. The location of the Tata Iron and Steel Company, Tisco in Jamshedpur, is a perfect 20th century manifestation of Weber's weight losing location triangle. Okay, this is the Jamshedpur. R2 means Jharia Ranigans, R1 Guru Mahisani, and M Calcutta Port. Okay, raw material 1, iron ore, Guru Mahisani within 100 km, heavy weight losing input. This one. Raw material 2, coal, Jharia and Ranigans, market M, Kolkata. The centroid, that means Jamshedpur, situated the exact optimal transport distance from heavy inputs. from this bolstered by the Subarnarekha River water and ship regional labor. The Lowe's challenges cost versus revenue. Alfred Weber's theory dominated for decades, but it possessed a fundamental blind spot. It assumed consumer demand and pricing were completely static. Alfred Weber in 1909 least cost theory and August Lost in 1940 maximum revenue theory. We will discuss later about this theory. And Alfred Weber assumes price is fixed, focuses entirely on the supply side. The winner is the factory that minimizes the cost of production and transport. On the other hand, according to August Lost, he argued that manufacturing costs are largely similar everywhere. Therefore, the winner is the factory that looks where consumer demand is highest, allowing them to capture the maximum possible revenue. Okay, the modern reality set in a globalized, digitized economy, Weber's sterile laboratory conditions have been heavily disrupted. 1999 isostopic surface assumes a perfectly flat plane like this with uniform transport cost everywhere. 1999 localized inputs of markets focused on a single plane sources, inputs and selling products within a confirmed area. Heavy transport costs are significant, often dominant factor in location decisions. On the other hand, in 2024, the death of the isostopic surface, government interventions like SEZs and tax subsidies artificially warp transport and production cost. Global value chains, GBC's single product factories are replaced by multinational corporations, raw materials and markets are worldwide. The rise of footloose industries, the IT corridor relies on digital infrastructure, transport costs for data are zero. Agglomeration is now the primary driver. Okay, these are distinction between 1999 and 2024. Okay, this is a century level differentiation. The enduring legacy of spatial geometry, the specific variable have evolved. Transport relies on refrigerated containers rather than steam trains, and labor is highly mobile, yet Weber's fundamental architecture remained intact. Alfred was the first to prove that geography is not as a backdrop for business, it is a measurable mathematical force on the balance sheet. The tension between distance, human capital and shared infrastructure remains the undisputed bedrock of global supply chain strategy today. Okay, that's all for today. If you have any doubt and query, just let me know in the comment section. Thanks for watching. Thank you.